You think you understand fire. You've watched flames your entire life. Candles flickering on birthday cakes. Campfires crackling in the woods. The blue ring of your gas stove. You've seen fire 1,000 times, maybe 10,000 times. You think you know what it is. Heat, light, destruction. Simple, wrong. When someone asks you why fire exists, what do you say? Things burn. It's a chemical reaction. Combustion. Those aren't answers. Those are words. That's just repeating terminology without understanding anything at all. Real understanding means knowing what's actually happening at the level of atoms, at the level of energy, at the level of the universe's fundamental rules. And when you dig into what fire actually is, when you strip away the comfortable surface explanations and demand to know what's really going on when something burns, you discover something so beautiful, so perfectly interconnected with everything else in nature, that it fundamentally changes how you see the world. Fire is not just a phenomenon that happens. Fire is a window into atomic behavior, energy transfer, stellar physics, and why trees exist in the first place. Fire connects you to the sun. Fire connects you to the very structure of matter. Fire reveals that you yourself are a slow motion version of the same process. Let me show you what I mean. If you've never questioned this before, you're not alone. Most people haven't. They see fire and accept it. But now that you're seeing it differently, there's no going back. Once you understand what's really happening when something burns, you'll see it everywhere. In your breath, in your food, in the light streaming through your window. You'll wonder why most people still don't get it. Start with a piece of wood. A dead tree sitting there, doing absolutely nothing, and air. Oxygen floating around, also doing nothing. The wood has been sitting there for years, maybe decades. The oxygen has been there the whole time. Nothing is happening between them. They're just coexisting. Atoms bumping into each other, bouncing off, going their separate ways. Millions of collisions every second, billions, and nothing happens. No reaction, no heat, no light. The wood just sits there. Why? Here's the fundamental tension that makes fire possible. Carbon atoms in that wood and oxygen atoms in the air want to be together. Not in some mystical sense, in the hard physics sense. Being together is a low energy state. It's more stable. When carbon and oxygen bond, they release energy, a lot of energy. That's where they want to be. That's the configuration the universe prefers. But here's the problem. To get together, they have to first get close. And getting close requires energy. There's a barrier in the way. Imagine a ball rolling along a surface. There's a deep hole it could fall into. A volcano crater. Once it's in, it's stuck. That's the stable state. But between the ball and the hole, there's a hill. The ball has to climb that hill first. If it's rolling slowly, it starts up the hill, loses momentum, and rolls back. It never reaches the hole. It never knows the hole exists. But if you could make the ball go fast enough, it would crest the hill and fall into the crater. That's what's happening with wood and oxygen. Carbon and oxygen want to snap together. But at room temperature, the atoms aren't moving fast enough. They collide, but they bounce off before they can react. The oxygen hits the carbon, starts up the energy barrier, doesn't have enough momentum, falls back, over and over, countless times per second. Nothing happens. A piece of wood can sit in the presence of oxygen for 1,000 years. Nothing. The atoms want to react, but they can't get over that barrier. Now strike a match. What happens? You're heating a small spot on the wood. You're making the atoms in that spot jiggle faster. Temperature is just atomic motion. The hotter something is, the faster its atoms are vibrating, bouncing, colliding. When you apply heat, you're speeding up those atoms. A few of them start moving fast enough to get over the barrier. They collide with oxygen atoms, and this time, they don't bounce off. They snap together. Carbon dioxide forms.
Atlantis on its way.
Here's
all
the
three
key, that
engines now
snapping
throttling
releases
down
energy.
as the area begins.
That energy
the
doesn't
passes
disappear.
through the area of
It makes the
maximum
surrounding
dynamic
atoms
pressure.
move faster. Those faster atoms now have enough energy to get over the barrier themselves. They react. They release more energy. That energy speeds up more atoms, more reactions, more energy, more reactions. This is an exponential cascade. A chain reaction, one reaction triggers two. Two trigger four. Four trigger eight. Within a fraction of a second, you have billions of atoms reacting simultaneously. That's why fire doesn't start gradually. That's why it explodes into existence. It's a runaway feedback process. Once it gets started, it feeds on itself. The heat produces reactions. The reactions produce heat, around and around. Self-sustaining catastrophe. That catastrophe is fire. The flames you see, the heat you feel, the light dancing in the darkness. That's this chain reaction made visible. Atoms are snapping together by the trillions, releasing energy, making other atoms snap together, releasing more energy. The glow comes from electrons getting excited. When carbon and oxygen bond, the energy released kicks electrons into higher energy states. When those electrons fall back down, they emit photons, light. Different atoms emit different colors. Sodium burns yellow, copper burns green, strontium burns red. That's how fireworks work. Different chemicals have different electron configurations, releasing different wavelengths of light when they burn. The heat you feel is just atomic motion transmitted through the air. Those jiggling atoms bump into air molecules. Those air molecules bump into your skin. Your nerves register it as warmth. Heat is not a substance. It's not a fluid that flows from hot to cold. Heat is motion. Fire transfers that motion to everything around it. Now, here's where it gets uncomfortable. You're realizing that everything you thought you knew about fire was incomplete. That feeling, that mixture of excitement and frustration, that's growth. That's your brain rewiring itself around a deeper truth. How many other things do you accept without questioning? How many phenomena do you see every day and never actually understand? Fire is just the beginning. What else is hiding in plain sight? Here's what should really disturb you. The wood was just sitting there. The oxygen was just floating there. They've been together for years. Why didn't the fire start on its own? If carbon and oxygen want to be together so badly, why do they need your match? Because they're trapped. It's called a metastable state. The system wants to change. It wants to reach that lower energy configuration, but it can't get started without help. Picture a boulder balanced at the top of a hill. It wants to roll down. That's the lower energy state, but it's sitting in a small depression at the summit. Stable as long as nothing disturbs it. But give it a nudge, just a small push, and it rolls down the entire mountain, releasing enormous energy. The wood and oxygen are that boulder. The match provides the nudge. This is why the universe doesn't just spontaneously combust. Metastable states are everywhere. Gasoline and air sitting peacefully in your car's tank. Food and oxygen waiting in your refrigerator. Hydrogen and oxygen, the components of water. Devastatingly explosive when combined, yet perfectly calm when already bonded. They're all waiting for triggers, sparks, catalysts, enzymes, something to get them over the initial barrier. And once they start, they run. Now let me take you somewhere unexpected. That piece of wood. Where did it come from? A tree, obviously. And where did the tree come from? This is where almost everyone gets it wrong. People look at trees and think they come from the ground. You plant a seed in soil. The tree grows. Clearly the tree came from the soil. Wrong. Think about it. Really think. Where did the mass of the tree come from? A tree can weigh thousands of pounds. A seed weighs almost nothing. The soil must have lost thousands of pounds, right? Here's the experiment. Take a pot of soil. Weigh it carefully. Plant a seed. Water it for years. Let the tree grow tall and heavy. Now dig up the tree and weigh the soil again. The soil weighs almost exactly what it did before, maybe slightly less from minerals absorbed. But the tree gained hundreds, maybe thousands of pounds. Where did that mass come from? Not from the soil. The soil didn't lose it. The Dutch scientist Jan Baptist van Helmont did this experiment in the 1600s. He was trying to figure out where plant mass originates. He weighed everything meticulously. His conclusion, the tree didn't come from the soil. He thought it came from water. Close, but not quite. The bulk of a tree comes from the air, carbon dioxide, CO2 floating invisibly around us. Trees breathe it in through their leaves. They rip it apart. They keep the carbon and build their bodies out of it. Wood is solidified air. The oxygen, that's waste. Trees spit it back out. They don't want it. They discard it. Every piece of wood you've ever burned was made of carbon pulled directly from the atmosphere. When the tree assembled itself from air, the water came from rain, which came from the sky. The minerals, the tiny amount that comes from soil, that's what becomes ash when you burn wood. Everything else, the wood itself, the substance that fuels your fire, that was air. Here's the profound part. How does a tree rip apart carbon dioxide? Carbon and oxygen are bonded tightly. That's the whole point. That's why fire releases energy when they snap together. They want to be together. So how does a tree undo that bond? Is there some mysterious life force, some special property of living things that defies physics? No. The sun does it. Sunlight streams down and provides the energy to push oxygen away from carbon, Photosynthesis is the tree using solar energy to do work, real physical work. The sun is constantly pumping energy into the system. That energy gets used to push molecules away from equilibrium, to create order out of disorder, to build structure where there was none. The tree is a solar-powered carbon capturing machine. It spends years, decades, sometimes centuries collecting sunlight, photon by photon, using that energy to break carbon dioxide apart and assemble itself from the pieces. We're about to connect everything. But before we do, ask yourself, are you the kind of person who actually follows through, who takes knowledge and does something with it? Because what comes next isn't just information. It's a lens that will change how you see fire, trees, sunlight, even yourself. And you can't unsee it. Now light that wood on fire. What happens? All that stored energy comes pouring out. The carbon the tree worked so hard to separate from oxygen is collapsing back together. The bonds that took years to break are reforming in seconds. And the energy that was stored, the sunlight that went in, that's what comes out as heat and light. Fire is stored sunlight escaping. A log burning in your fireplace is the sun shining again. The photons flickering in those flames, that sunlight that fell on leaves 5 years ago, 10 years ago, 50 years ago, stored as chemical bonds, released all at once. Every photon from the fire is a recycled photon from the sun. The energy is the same. It went in as starlight, got stored as molecular structure, and comes back out as firelight. The carbon dioxide rising from your chimney is the same carbon dioxide the tree absorbed decades ago. It's a cycle. Carbon circulating. Oxygen circulating. Energy flowing from the sun through plants, through fire, and back to the atmosphere. Here's what should blow your mind. You're part of this cycle too. When you eat food, you're eating plants or animals that ate plants. That food contains carbon that trees pulled from the air. Your body burns that carbon. It combines it with oxygen you breathe. It releases energy. That energy powers your muscles, your brain, your heart. The carbon dioxide you exhale is the same carbon dioxide the plants absorbed. You are, in a very real sense, a slow-motion fire. The same chemical reaction. Carbon plus oxygen yields carbon dioxide plus energy. The only difference is speed and control. Fire does it all at once, releasing energy as heat and light. Your cells do it gradually, carefully capturing the energy in useful molecules like ATP. But it's the same process, the same chemistry you are burning right now. Every breath you take feeds that slow combustion. Every exhale releases the waste products. You are solar powered just like the fire. The food you eat stored sunlight. Your metabolism releases it. You are a walking, thinking expression of the same physics that makes flames dance. Think about the oxygen you breathe. Where did it come from? From trees, from plants, from billions of years of photosynthesis. The early Earth had almost no free oxygen. The atmosphere was carbon dioxide, nitrogen, methane, water vapor. Then photosynthetic organisms evolved. They started dumping oxygen as waste. For them, oxygen was poison. Many early life forms died when oxygen levels rose. It was a catastrophe. But some organisms evolved to exploit it, to use that oxygen to burn food more efficiently. Animals evolved. We evolved. We breathe the waste product of ancient plants. The atmosphere you depend on is a byproduct of life learning to capture sunlight. And this brings us to the final question. The question that underlies everything. You've seen how fire works. How atoms snap together, releasing energy. How trees use sunlight to pull them apart. How the carbon cycle connects sun to plant to fire to atmosphere and back. But where does the sun get its energy? The sun is doing something even more extreme than fire. It's not combining atoms, it's fusing them. Crushing hydrogen nuclei together so hard they become helium. The sun is a nuclear furnace. Temperatures at its core reach 15 million degrees. That's hot enough to overcome an even bigger barrier than the one between carbon and oxygen. The nuclear barrier. The barrier that keeps protons from sticking together. Every second, the sun converts 600 million tons of hydrogen into helium. 4 million tons of mass simply vanish, converted into energy by Einstein's E equals mc squared. That energy radiates outward as light. That light crosses 93 million miles of space. It hits a leaf. It breaks apart carbon dioxide. It builds a tree. You burn the tree. The sunlight escapes. So now what? You've just spent these minutes fundamentally changing how you understand reality. That's not nothing. That's rare. Most people never have this experience. The question is, will you remember this tomorrow? Next week? Or will it fade like everything else you've learned and forgotten? There's a way to make sure it sticks. There's a way to prove to yourself that this mattered. Fire is not just combustion. Fire is the universe's tendency toward lower energy states made visible. Fire is the release of ancient sunlight. Fire is the same process that powers your body, your thoughts, your existence. When you watch flames flicker, you're watching physics in action. You're watching atoms finding their preferred configurations. You're watching stored stellar energy finally escaping. You're watching the same chemistry that keeps you alive, just faster and brighter. Isaac Newton figured out that the same force making apples fall makes the moon orbit. That was unification. Understanding that disparate phenomena share underlying causes. Fire does the same thing. It unifies combustion, respiration, photosynthesis, and stellar physics into one coherent picture. Carbon wants to bond with oxygen. Sunlight can break them apart. Life exploits that separation. Fire reunites them. Your metabolism does the same thing slowly. It's all one process, one cycle, one flow of energy from stars through matter and back. And this process, this avalanche of understanding, started with people asking simple questions and refusing to accept word-salad answers. Antoine Lavoisier in the 1770s figured out that combustion requires oxygen, overturning the phlogiston theory that had dominated for a century. Jan Ingenhouse discovered that plants need light to produce oxygen. Albert Einstein explained how mass converts to energy. Hans Bethe worked out how stars fuse hydrogen, each discovery building on the last, each insight opening doors to more insights. That's how science works. That's the avalanche that's been rolling for 400 years. And we're still avalanching along at high speed. Fire isn't just a thing that happens. It's the key. It's the window that reveals how energy flows through the universe. It shows us that we're not separate from nature. We're part of the same cycle. We're made of atoms that were forged in stars. We're powered by sunlight stored in chemical bonds. We exhale the same carbon dioxide that trees breathe. When you burn a log, you're participating in a process that connects you to the sun, to ancient forests, to the fundamental structure of matter itself. The fact that we can understand this, that we can trace the path of energy from nuclear fusion to photosynthesis, to fire, to metabolism, that's the beauty of physics. Not comfort, not simplicity. Truth. If you made it this far, you're part of a small group. The group that doesn't settle for surface explanations. The group that wants to understand, not just know. People like you, people who think like this, they find each other. They recognize each other. They build on each other's understanding. That's how the avalanche continues. That's how we keep discovering, not alone, together.